material, the code requires the manufacturer to verify the identification of the material. It requires them to inspect the material for defects, and you have to inspect the material for thickness per the drawings and calculations. So these are all the things that the code goes into. And then where people start losing it is most people think that pipe material is required to be traceable to an MTR per the code. Well, not so. Section 8 Division 1 does not require that pipe material to be traceable to the MTR. It acknowledges that having the material specification, the heat number, the schedule or the thickness, it identifies all that stuff as being acceptable to accept the material and not take it back to the MTR. Whereas plate material, it specifically states plate material has to be traceable to the MTR. You got to trace it back to that MTR. And that's where people run into the problems, because MTR's heat numbers are usually 12, 13 numbers. And then one thing a lot of people miss is the lot number. So after the heat number on plate material, you put that -01, -02, whatever they put for their lot number, depending on that manufacturer, that material manufacturer. And then what happens is if someone leaves that lot number off, if that heat number has 5 lots, all 5 lots are listed on the MTR, and all 5 lots have their own specifications of what the material composition is. And as a manufacturer, we are required to verify that the MTR meets the material composition that's required by the code. We're required to verify that the thickness of the material is within the boundaries of the code. So plate steel has a under tolerance of 0.01 or I think it's like 6% of the.
You're talking about the plate thickness?
Yeah.
Oh gosh.
I
know pipe
so
is
if you
12 and a
order
half,
like
but...
half-inch plate,
Yep.
It's actually the lesser of 6% or 0.01. So if you order half-inch plate, you can physically receive plate material at 0.49, and it's acceptable, even if your calculations require 0.50. It's still acceptable, even though that material is physically thinner than what the material calls out for in the calculations.
So how would you verify that in your calculations then, once actual material is received?
You wouldn't. You calculate off a nominal size.
And then upsize the thickness to the next available
So
plate.
the calculations already account for that variability. So you have situations where you have what I think it's 25% margin in most of the ASME calculations already. That's to help account for those smaller variations. But yeah, so we're fine in that. The only part where we have to account for that is in piping, because they allow I think 12.5%. So it's a huge variability. But that's already in the calculation. It's already there.
And to Rob's point, pipe's already considered pressure retaining, whereas plate's not. That's why the traceability needs to continue forward with the...
So plate material actually can be turned into multiple different things.
Yeah.
Okay, you can turn it into a pipe, you can turn it into a shell. I mean, you can do
Make
a
it a
whole lot of
box,
different things.
whatever,
Yeah.
You change the thickness.
Whatever.
If you have a ellipsoidal head,
So-
I mean, you have all sorts of variable thicknesses.
Because of that, that's where we need to make sure we maintain traceability all the way back. But the thing I want to bring up about us is, while code doesn't require us to maintain traceability of pipe to the MTR, we do it anyway.
Well, our quality procedure manual requires it.
Exactly.
And no customer, well, I don't think we have any customers that can accept it. They want the MTRs.
Sure, yeah, and the traceability is important for us, down to the composition of the Sharpie that's used to write on the piping when it's stainless steel.
The low chloride.
Low chloride on the marker and all that.
Yep. So.
Yeah.
All right, well, let's dive into this. Vaughn, this is the Process Systems Podcast. Joining me today, I got Dennis Ovens, our engineering manager here at Vector Systems, and I got Rob Troutt, who is the former authorized inspector for the ASME Section 8 tanks. Is that correct?
Well, I'm the former chief inspector for the state of Texas, and I oversaw the joint review program for the state for 14, 15 years. So I was a lead team leader.
Well, we're talking tanks today, so we're going to dive into it. One of the things that I wanted to bring up is, are there tanks that Vector Systems builds that require extra care or extra design effort? And this is kind of from the quality and code compliance perspective, but also the design and engineering perspective. We build a number of different tank variables, whether it's a horizontal bullet with heads on it, whether it's a vertical cylinder, whether it's a box. For most of our ASME Section 8 pressure vessels, is there a design type that is more stringent or complex than say another one?
You either have low temperature materials or extra thick, because then you have to worry about heat treating. But then you also have to make sure your weld procedures are qualified for heat treat. But then also, will be heat treated anyway, is anhydrous ammonia tanks, because they have I just blanked on the spec, but we have extra specs that aren't ASME for those. Right. So ASME wise, they don't care what processes, and as long as it's considered lethal, that's the only time they really.
Well, ammonia is considered lethal service, and
Depends.
Both ANSI K61.1 and CGA 2.1 require post-weld heat treat for stress corrosion cracking during manufacturing.
Also requires excess flow valves, and if certain nozzles don't have excess flow, you have to drill like a .050, so a really small hole through the tank shell, so you have a small orifice. So pressure gauges get the pressure, but if something breaks off, you're not dumping the whole tank of anhydrous out. But that's on top of the ASME stuff. So that's a secondary set. ASME wise, like I said, I don't think ASME really cares what's in it, as long as it's holding the right pressure, temperature, and you're taking care of the corrosion, seismic, and wind loading and stuff. So I mean,
well, and when we started rolling, we were in the process of talking about material traceability, but the AI doesn't review the calculations from the standpoint of material suitability. Is that correct?
That's correct. So when we start talking about the duties of the AI, we can find that in UG 90, and there's actually kind of 3 sections to UG 90. The first section is basically just says that you have to follow this section, but then UG 92 is the duties and responsibilities of the manufacturer. And then UG 90.3 is the duties and responsibilities of the authorized inspector. So if you go into UG 90.3, it talks about the authorized inspector is required to, one, ensure that the manufacturer has a certificate of authorization issued by ASME, giving them the authority to apply the certification mark to show that the vessel was built, designed, fabricated in accordance with the code. So that's kind of the signature mark of it. But then we get into the other parts of what the AI is required, and it goes in and says he has to verify that they have a quality control system. Sure. Okay, well, every manufacturer that builds to the code has a quality control system, but the question is are they following it? Okay, so that AI actually has to know what that quality control system is, and he does periodic checks to make sure that we're following it. So he has to do that. He also has to verify, as you said, that we have drawings and calculations. He doesn't have to verify that they're accurate. Right. He just says you have to verify that they have them. Mm-hmm. So that's but UG 90.3 is where you go to find out what his details are.
Do you also look at the weld procedures and make sure that the ones that are being utilized and being provided match what's on the drawing and so forth? Do you go into that detail?
Well, yeah. So as QC for Vector Systems, I will go in and when a job comes in, I'll take the drawings and calculations and I'll bounce the drawings against the weld procedures. Okay, that's listed on the drawings because that's where we list them. And then I'll go in and say, well, is this the right weld procedure? Are we dealing with P8? Are we dealing with P1 material? What type of material are we dealing with? Are we dealing with stainless steel? Or are we dealing with carbon steel? Because we got to keep those apart. You can't let the chlorine
cross
get
contamination.
Right. You can't have the cross contamination. So we go in and we make sure the weld procedures are listed in there. I go through the drawings and calculations, and I figure out what the minimum thickness is required per the calculation for each component. And then when I go and do the receiving inspection, I have a D meter, an ultrasonic thickness tester, and I'll put it on there and I'll check it and make sure that it meets the requirement. As you go through UG 92, some of the things is very explicit on what is required by the manufacturer when it comes to material.
From a design perspective, we go through and we utilize calculation software that checks code compliance. But ultimately, Vector Systems is responsible for the process design, but as well as the mechanical integrity of the equipment.
Well, also we're ultimately responsible for the calculation because ASME doesn't have their own calculator. Majority of people use Code or Compress. We're one of the many people use Code or Compress. But if you know what you're doing, you can still make something that it thinks is perfectly fine, legal, capable, probably be okay. But it's not passing code because it's not actually. Some people get the feeling that if it passes the calculator, it passes code. Sure. It's not code. It is a supplemental calculator. You still have to be responsible for all the details of it. So yeah, you can trick it to make it say something's right. Doesn't mean it is right. So you still have to go through and you have to know the code correctly to actually calculate the tank correctly.
And it's not testing it to failure either. It's just saying whether or not it can safely contain that pressure based on the parameters you told it, correct?
A little bit of column A, a little bit of column B.
Okay.
But ultimately, though, it is a supplemental calculator. It's not the actual authority on anything. That's also one of the reasons why we have AIs inspect. That's also one of the reasons why I'm not the only person doing code calculations. But I'm the one that has to review their code calculations. Absolutely. Because they can make it work completely correct, but it's the wrong material, or they can have it completely correct and seismic conditions are wrong, or a bunch of different things, which those would be more along the lines of not input errors, but more along the lines of just implementation errors. But that might change during a job. Yeah. They might say, hey, it's going to, I don't know, Arkansas, and there's no big deal. But then you realize it's the Newberg Grid fault line area, and that's a whole other set of problems. But code doesn't. Code tells you have to account for it. And luckily, Compress has calculations in there for it, but you have to know what to look for and what to put in. So I can put in plenty of wrong information and get a great-looking tank that does nothing.
That doesn't meet what he's looking for.
Or even the design criteria of what we needed it to do, because luckily we haven't had that happen, but it's not hard to do if you don't know what you're doing.
And I think that's where the experience in building pressure vessels really comes into play. I looked at some preliminary numbers, and I think Vector Systems done a little over 180 pressure vessels in the last 10 years. And that's come with a lot of taking our standard design practices, incorporating the code requirements, also incorporating client requirements, specifications, and also making sure that it matches all the local governance and those type of things as well.
Correct. Yeah. The calculator Compress will not do that. Heck, ASME won't. They don't account for local jurisdictions or anything like that either. So it's one of the many columns you have to pay attention to. So when we do designs, it's the code minimums, our customer requirements, and then our minimums. Mm-hmm. So whichever one is the minimum has to at least be met for all three categories. Sure. Ideally, we take the worst of the three and we meet all three of those. But sometimes, customers ask for stuff that is not required, and we can come back and say, do you really need X, Y, Z? Because this spec is for a whole power plant, mm-hmm. and we're doing something that's at 10 PSI, mm-hmm. Which is, I think it's under the level of ASME. ASME starts ideally at 15 mm-hmm. PSI, but we have customers that still say they want a vaporizer running at 2 PSI to be a pressure vessel.
We're dealing with this right now where, something we would normally design and build towards piping class is now getting ASME Section 8 Division 1 pressure vessel requirements put on it, even though it will never see those pressure requirements. And it necessitates building it in a code shop. It necessitates relief valve and all these other things that are above and beyond what our standard ammonia vaporization package would include.
We can get away with a few other things there, because what you said about the PSV, one of the requirements is makes you have overpressure protection. Like if the system can't make the pressure, you don't have to have a PSV in it. So like some stuff we have, it's only being pressurized by a blower. A blower is only going to give you 45 inches of water column. It's not a compressor. It can't go up to 300 psi and blow out the side of the pipe. If it stalls out, it's backing out through it's just stalling out the blower. Yeah. We're going to max that at 2 psi. And correct me if I'm wrong, but you obviously know the code a lot better than I do. But that's also why you're here.
The inspector doesn't look at the process, though. You look at tank design and the requirements. You mentioned the UG paragraphs, and I think those are implicit to the manufacturing and quality control and material aspects. There's also the process design, which we specialize in. There's also the mechanical integrity design that may be specs on specs in terms of complying with code minimums, then client requirements, then maybe even material traceability beyond that, like PMI or something of that nature. And that's where we come in as Vector Systems to say, hey, this tank is not just an ASME pressure vessel, it's an ASME pressure vessel that also meets the following requirements.
Well, one of the things we have to deal with is, you said I think 180 tanks. For a tank shop, that's not many. We're not a dedicated tank shop. We happen to have tanks in our system, so we implement them. But I mean, we have tanks that are designed down to, like I said, 8 psi because the customer demands it. Then we have other ones designed up to 2,400 psi, and cold temperature, hot, everything in between. So they vary drastically between them. So I mean, there's a lot of potential gotchas that we have to take account for, and there's, like I said, there's code requirements, there's customer requirements, there's local jurisdiction requirements too, which those can actually almost go in the face of the other ones.
Yeah, right. Agreed.
So you're in a situation where you have to talk to the customer, which one are we going to be following? Because also we're not an engineering company where we design and manufacture product. So I can't be responsible for site conditions. I have to tell the customer, hey, you have a conflict, I need you to resolve it. I might give a good suggestion, right, but I can't be telling them what to do because we're not an engineering firm.
You brought up 2,400 psi. I want to piggyback on that because this was one of my questions I had for this discussion was, right now we are ASME Section 8 Division 1 certified, and we build hundreds of tanks of that style for our own processes and process equipment we support multiple industries with. We get a lot of inquiries from everything from scuba tanks to submarines, and we like the SUV size in many cases. Higher pressure, what does ASME Section 8 Division 1 go up to?
Technically, it goes up to everywhere, but the calculations max out around 3,000 psi because you'll be getting like 6-inch thick vessels. Sure. And then you can go to Division 2, which is good from like 3,000 to 10,000, and then Division 3 is 10,000 up. But that's also just unfired pressure vessels. And then we also have a Division 1 boiler stamp, not Division 1, sorry, Section 1. It's Section 8 Division 1, and then a Section 1 stamp, which we've had, and we've never actually had a chance to implement, but we were going to be doing that for boilers for economizer tubes, which every time we go audit, I do a hand calculation to prove I know what I'm doing, but we haven't actually had a chance to input. So if anyone wants to sell us some economizers, we'll build them for you. But it's 2-inch pipe. It's 2-inch pipe. It's not rocket science, but it's required because it's part of the pressure envelope of the boiler.
Yeah, and I think it depends on the application, right? I think at what point do we go get recertified and have Division 1, 2, I don't know about 3, but to add that certification to our repertoire, at what point do we look at doing that, right? I mean, you mentioned economizers. I know from a product development standpoint, that's one area we want to get into, from fuel gas, water bath heaters, and potentially even smaller economizer packages, heat exchangers, shell and tube.
And water bath heaters fall under, I think, Section 4. Section 4? Depending on how much heat you put into it. Right. So ASME will let you do a lot of things, so you have to know what code to look at. And there's a lot of little gotchas that no one tells you until it's time for inspection time. And then if the inspector's used to looking at tanks, they might not even know that they don't know what that 8-inch flange is for. True. Now, if we're being honest with them, telling them we're going to stick a heater in there that's going to dump, 50 something thousand BTUs, that puts you outside of section 8.
Well, and we can do S-stamp piping for power piping as well. I know a lot of times we designed a piping code because a lot of things are made out of pipe in our facility. And then at what point do you call a pipe with 2 flanges on it a vessel, right? That becomes another discussion as it comes down to what are the requirements. If it's
Ultimately, though, that is the call of the customer, because once again, we're not the engineering firm. There's an EPC with engineers that need to be telling us. We can tell them, hey, this matches B311 exactly. There's no reason to do Section 8. And they can come back and say, no, everything has to be Section 8. And hopefully we have that correct on the quote, and we're good to go. Or it's a change order, the scope changes. So.
And a lot of times that is directly driven from the jurisdiction themselves.
Yeah.
So, like Texas, we only regulate boilers. So, Section 4, Section 1, there are Section 8 unfired pressure or unfired boilers. We even have nuclear boilers here. So, but when we go in and we start installing these things wherever they go, if we don't go to that jurisdiction and find out what they regulate, we may be building something where that jurisdiction regulates pressure vessels, so they actually do in-service inspections on them, and they assign a jurisdictional number to it, and they require that it be built to ASME Section 8 Division 1. And if it goes to be installed in a location and it's not registered with the national board or built to ASME, that jurisdiction will say, get it out of my state.
Yep. And I don't know whether that's what current issue we have, because we've had stuff designed, let's say designed to, but not stamped. And in Texas, it's sure, why not? But ultimately,
I mean, every one of our AIGs is that way. We designed a piping code, but it's not.
Well, you can't
designed to leak.
There's hundreds of holes in it.
Right.
So I mean, where are you gonna?
I mean, it's structurally built to ASME B311 or 3, depending on where it's going or what it's doing. But as an AI, if you were going to come witness a hydro test for piping code, you're like, how come this hadn't been hydroed? Well, it's got 1,000 holes in it. At that point, you're splitting hairs between design to and stamp to and so forth.
Well, they're unfortunately very important hairs to be split.
Right.
Because if you're going to a jurisdiction where this has to be this, okay, who notified us that it had to be that? Now, either fairly, unfairly, or just my opinion, I think that's responsibility of the customer to tell us what's the requirement of the site, because we're signing a contract to them. It's like, we're building this tank for you, or we're building this piping for you. It's designed to go to Texas because it's easier. But if the site has extra conditions, they normally will supply us a document that says these are the other codes that are we subject to, and they'll be California codes. There'll be Saskatchewan building. I don't know if Saskatchewan has one, but I know there's multiple provinces. Alberta has its own. His own building code that looks at first glance the exact same as everyone else's, except they have Canada on top of it. And of course, there's going to be one paragraph somewhere that you don't notice,
right,
that their inspector knows to go straight to.
ABSA with the CRN numbers and the registration requirements with that. And to your point earlier, building it to ASME code is almost the minimum. And we start there, and oftentimes, to get something with a CRN number in Canada, it's better to say, hey, it's a ASME Section 8 pressure vessel, and you apply the Canadian jurisdiction codes to it as well.
Well, that's the other thing, too, is a lot of these codes will have if, thens, or buts. So, like, we do a lot of structural code. So they have, the structural code books have their own weld procedures, or use your ASME procedures. Well, we don't. We do ASME pipe welding for everybody, so they already have the ASME procedures down. So we just tell everyone we use those, not the prefabricated, weld procedures in the books, because we already have certified weld procedures that have been tested with ASME. But I mean, if you're going to do a Section 8 tank, you don't really care if we have Canadian welding certifications. But if it's going to Canada, we have to care about it. And I guess you do now since you work here, but but
So
before.
I'm kind of versed in Canada as well because, well, I had vessels when I was an authorized inspector for Hartford. Before I went to the state, I had to deal with that. But even since I've been to the state helping out when I was working for the state, I helped out some of the fabricators here in Texas, work with the individual Providence because I know all the chiefs. And I was actually helping one company get their CRN number. And it's with vessels that are built in Canada, that stay in Canada, when they build them, it's built to ASME code without the certification part of it.
Sure, it's a Canadian certification.
Right. The Canadian certification is they require everything to be built to ASME code, but then you do their certification. You have to have their inspector, not an authorized inspector. So in all the provinces of Canada, the chief inspector in most of them, and it's kind of fading away now, but Alberta, Ontario, they are the AIA. So the government is the authorized inspection agency. So their people have those inspectors. And when we send in our designs to get a CRN in Canada, it's going to their engineers that are just going through it and making sure that it meets everything, that all that's required for code.
But ASME in the States is an insurance code. I had to be very blunt about it. So, and likewise, though, other jurisdictions have decided to use it as their actual legal code, but the nuts and bolts of it is it came from an insurance code because I'm not going to insure something unless I know it's built correctly.
It
How do I know
started
it's built
with
correctly?
some pretty tragic accidents of vessels getting overpressured and exploding, causing the deaths. And actually, in Texas history, that's why natural gas now has a scent. Is that they started making it to where if it does leak, it'll prevent people from not noticing. One of the questions I had in regards to talking through the governing bodies and stuff. A lot of times a customer will reach out and say, hey, here's a picture of this crusty nameplate that's been here for 1 million years. I'm looking for something similar. I'm looking to replace this. And they give you the national board number. What on file with the national board is available to go look up with that reference number? Are there design drawings and stuff like that are stored for each national board number?
No.
In an archive or anything?
So when a manufacturer registers a vessel with the national board, all that is the registration of the manufacturer's data report, which is in essence the birth certificate of the vessel. Sure. Yeah. So that's what we fill out when we finish building it. It's been hydro tested. Representative of the manufacturer signs it, and the authorized inspector actually has to sign it. And that's what says this vessel is code.
Yeah, but it'll tell you the materials, how many nozzles.
Well, it doesn't.
That's about it.
It'll tell you what the material is.
Yeah.
It'll tell you the thickness, and if it's filled out halfway correctly, it'll even tell you what weld joint the nozzles were attached in. Because when you're filling these out, one of the things that Section 8 wants is they want to know, one of the questions that says, okay, list out all your nozzles. What's the material spec? What's the thickness? Does it have a flange on it? How is it connected? A lot of people just put welded. But if you look into Section 8, Division 1, and you go to UW16, it actually has a bunch of different of pictures of joint designs. And it tells you what type of joint design. So what ASME is actually looking for in there, you can put welded and they'll accept it. But if you put UW16, say C, well, that tells engineering exactly how it was welded, and then they can go in and reverse weld it or reverse engineer it.
Now, from a reverse engineering
I never get that part though. I get welded everywhere.
100%. And
if I get that much,
We don't put welded anymore.
Okay, good.
the reverse engineering aspect of it is kind of important here too, because I don't know that just with that birth certificate, just with that registry, you could get any dimensional information or anything like that.
You'll get shell size and thickness and some other nominal things, but I'm not going to know. It might say there's 16 2-inch 150.
You don't know where they are. They could be all on one side, or
Yeah. You'll have no idea where they're at, but you'll know how many nozzles are on it. You'll know what the shell thickness is. You'll know what the head thicknesses are, what type of head, if it has a transition in it.
RT.
Yeah, RT, post-weld heat treatment, any treatments it's had to it.
But we also have an R stamp, which luckily we haven't had to R stamp something in the field like that because it'd be a nightmare because you have to inspect everything in it because one of the things is it'll have a corrosion. Say it's 3/8 wall, but you have 1/8 inch corrosion, and so we have to make sure that's all at least a 1/4 inch thick because if it's not, redo everything because that's technically end of life for that component.
And also from like a retrofit perspective, where if we're replacing an existing tank or something like that, that information may be helpful, but ultimately it's us going to the site to do a site engineering survey, to take measurements and get the tie-in points and get the elevations and also hear from the customer what concerns they've had over the life of this existing tank.
Well, not only that though, it's like if it's a really old tank, the code's changed a bunch.
Oh yeah,
It went from a 4-to-1 to a 3-to-1.
valid. Yeah.
So on our side, luckily, it could be thinner. And there's countless other changes that I don't know if a tank was made. What the code's been around for 100 years, 100 plus. If it's that old of a tank, I'm just going to ask them what conditions you want me to build it to. I'm just going to ignore that tank. We're going to put the connections. What are the new conditions, and go from there. We're not going to be the type of people who are going to go in and try to put in a new manway in that tank because it'll take probably more time to do that, unless it's some really specific condition, than just to make it from scratch.
Yeah, or ship it to our shop and do it under a controlled environment rather than in the field where you're taking a bunch of expensive field measurements on thicknesses and UT and all that stuff.
After you clean it out.
After you clean it, right.
From the
an
century of
in-service tank, yeah.
Yeah.
Yeah, and knowing what the service is really important because now by knowing the service and what's going on, you're going to know what internals it needs, where all the wear's going to be, from turbulence or whatever you got going.
That's a good point. Like we've done separators, mechanical separators, and I'll put an extra plate on the inside. It's not pressure retaining. Code doesn't care about it.
Nope.
So can you imagine going to repair one of those and all of a sudden you go in there's an extra plate?
Why is this plate in here?
Right.
I don't know.
Yeah, then you find out that the part that's not been reinforced is corroded out past its minimum, and you're still fine though on the part that's supposed to take the wear because it's got an AR500 plate or something on it. Mm-hmm. So.
Yeah, you mentioned other materials. That was one question I jotted down was, while primarily we build out of P1, P8, what other types of materials do you have experience inspecting on for ASME Section 8 vessels?
Actually, I've seen it all. Yeah. So when you get into materials and you start going into the design of it, while engineering has to go in and verify that material is permissible per use, which you find in Section 2, when we start putting it together, it's more or less us going in and making sure the material is, one, what they called for. Yeah. It's as thick as it's required for because that's what's required for pressure retention. And then we got to go in and do the joints and stuff like that. But different material, as long as there's provisions in Section 9 when you're talking about welding. And like if you qualify from on P1 material, you're good from P1 through P11.
Yeah. Your
procedure is good after it's qualified.
But if
if you want to go to say P12, well, now you got to qualify another procedure. So it just depends on what you're qualified for, on what expert stuff you're going to go into. If we ever get into boilers, you're going to get into P91 material, especially on big boilers. One of our big clients, Rentec, they use it a lot. I've done a lot of their joint reviews, and it's used a lot in the boiler tubes in the big boilers.
Yep.
So, and when you get into that P1 material, you got to be very careful when welding with it. So it's a little temperamental.
Yeah. Well, that's also one of the things too is we aren't really accounting for because the weld procedure might be fine for P1 through 11, but you have to do certain preheats and not post leachers, but ramping up and cooling down temperatures. Because if you have a chromoly, which I think is a before. Trying to go up all my corners memory right now. Like if it cools down too fast, you could crack it.
Right.
That's nothing the weld procedure tells
Yeah,
you about it.
control the cooling.
Now, it obviously will fail hydro, but that's one quality check. But that's just the code tells you majority of what you need to know, but there are certain things on top of it that are required to do. Because I've had people, that passes code. I'm like, it passes code, but I would never want to be anywhere near it because, I can make a 20,000 gallon tank out of a quarter-inch material. If it's low enough pressure, it's going to look like a water balloon, and it's just I'm not going to trust it.
Yeah. Well, it's wild too, because like I saw this video of they were 3D printing metal tanks, small tanks, and I was like, okay, well, number one, that whole thing is a weld procedure. Number two, what materials is that, and could that eventually, when the technology catches up, fall into
That'd be
ASME
like
Section 8?
ER70 or
That's already being addressed.
Is it?
It's
Yeah.
called additive manufacturing.
Sure.
Is that now being evaluated by
ASME's already looking at it, and we've already got items open, and we're addressing it on the MBIC. So I sat on.
It's a good question, and I want to hear more about this.
I sat on ASME for a while, and when I became chairman of the board of trustees for the national board, I kind of came off my ASME committees, and I kind of came off the MBIC committees that I was on. And since then, they've started coming out, and I got first exposed to it when Dr. Mark Lauer, who is a dear friend of mine, he worked for, or I think he still works for the National Labs, okay? And he actually did a presentation at the National Board's general meeting, and he had a sphere of an Earth that had a sphere inside it.
Oh, cool.
And it was completely made by a robot, the whole entire thing. So what they're doing is they're actually building propellers for large ships, anything that you can think
Gas
of.
turbine blades. All
Yeah,
sorts of
Complex
stuff.
geometry.
they are going in and they program it, and it starts an arc and it builds the entire thing just like a 3D printer.
Yep.
And
That technology's become pretty revolutionary. I know we see standard bullets and cylinders and silos and stacks, but now complex geometries for things like
That's going to be a nightmare to calculate. Because we don't do. Technically, you could do a square ASME tank. It would be.
we went
a
through this
nightmare.
with API 650, where we try to utilize the ASME Section 8 minimums to guide our API 650 design, and then apply all the additional requirements called out by the annexes and so forth.
Yeah, we pretty much just did API 650 at that, but we've had customers say, "Hey, I want a square tank to 100 psi." Like that's technically possible, but no. Once again,
Corners
what
are a problem.
is potentially allowed and what's practically doable, they often will be pretty close, but sometimes they just go their separate ways. So we have to know enough to go. No, that's while technically possible, you don't want to buy that thing. So I'm not going to build you a battleship, because you want me to build you a 8 foot by 8 foot cube that's holding 100 psi. No, no.
It's going to be a bolt at that point.
And Section 8 has a problem with square joints anyway.
Yes,
So they don't want to see square joints.
they allow flat sides, but you have to
Yes.
round the corner, and
Yep.
that's
All the stress,
It's a stress
concentrates.
riser.
Yeah, concentrates in the corner joint.
yeah. Luckily, they had a moment of clarity. So
Well, I think that advances in technology are going to, and I'm glad to hear that the National Board and National Laboratories and other folks are starting to identify this emerging technology as, hey, this is where manufacturing's largely headed for.
me, as someone completely ignorant in that category, it would have to be at least like a Division 2, because it's got to be totally FEA analysis if it has a complicated geometry. Because you're not going to have a good calculation for the minimum thickness for a weird S bend inside something. I can go from cone to cone. That's not overly complicated. It's not the easiest, but not overly complicated. But as soon as you start throwing out just free-form shapes, that's when you have to have a. That's when you're going into full FEA analysis, where you have the computer go, hey, I have 100 PS on the inside. Here's my shape. Here's my material type.
Look for stress concentration.
Look for stress concentration. Look for safety factors. Look for all the internal stresses. But that'd be really fun to do. But also, not luckily, but for what we do in our environment, for mostly industrial purposes, we're not trying to fit a tank in a nose cone. We're not trying to fit. We've done a tank in the nose of a boat, but that was still interesting.
It largely looked
you
like
largely
a
fit
tank,
it as a tank. Then the clever part was where we put all the attachments around the tank.
But we look at stuff for universities. We look at stuff for rocket laboratories.
Well,
we look at stuff.
We've had people ask for a 6,000 psi tank. I'm like, I could technically design one for you, but you're going to the wrong place right now. You need a Division 2 or Division 3.
Agreed. And one of the things we've been
There's provisions for in Div 1 to where you can design to Div 2 with the Div 1, right?
Yes, but we don't even have the Div 2 book. So
Yeah, well, that could be a problem then, because you got to go in and do that part.
That's forbidden knowledge.
So this year we've been capturing marketing data based on inquiries that have come in, and we've been sorting them by too high a pressure in that instance, in that example. And it's like, how many of these before we say, hey, it makes sense for us to diversify our prowess of manufacturing to say, now we're Div 1, Div 2. I don't know about Div 3, but
the current design book has some limitations with the requirements for designers. Like, you have to have so many years experience doing something. If you're not a PE, it limits you to what you already have experience in. So luckily, I was already doing this for 15 years of doing design stuff. So out of the 188 tanks, I probably did 160 of them.
And that's not including UL 142, API
Correct.
650, AWWA, all the other style tanks that are not ASME Section 8.
But I had the provable history that I was qualified to do tank design, but there's still certain parts of the tank design that in the current code book I'm not qualified to do anymore. And if I do, I have to get a PE to sign off on it.
Well, I'm going to make your life a lot easier.
Okay.
With the 2025 edition of the code, which is mandated January 1 of next year. So code's published July 1
Yes.
of this year
Yep.
is when it was published, and it becomes mandated 6 months after the published date. Appendix 47 has changed. Again,
Is it back to what it used to be?
it's back to what it used to be.
I'm guessing too many people couldn't keep their stamps anymore and lost a lot of customers.
Well, so it's actually comical because when Appendix 47 first came out, I saw a decline in ASME Section 8 Division 1 code stamps.
Oh, we had one of our sub-suppliers. They don't do it anymore. They asked us, do you want to...
Drop it. We ain't doing it no more. We had that happen, and ASME saw a drastic loss in revenue from
Money talks.
manufacturers dropping code stamps because of that. When they were asked, why did I do it? It's because you're trying to make me hire a PE to design a simplistic vessel that it doesn't need to be a PE.
And that maybe we've been doing for many years, and now we are no longer eligible for.
Well, there's even a caveat, at least in the older books. I haven't had to look it up in a while. It's like, if it's not in the book, but you have a proven track record of it working, continue. But now, PE stamp is really good, but it's. I'm sorry, but having a professional engineering license does not mean you know how to design a tank.
No, and
But
actually,
but according to the code book, it does.
But every time I've worked with a PE on these projects, they review your calculations and basically do the same thing that Rob would do. Is that I've looked at it, the material matches, the calcs look reasonable, they don't look crazy, and it has the necessary information required by code, and that's it. That's what a PE is going to look at. Are they going to go apply loads to our tank to see where it fails?
Yes,
Maybe.
yes and no. But also I've noticed with certain PEs or at least certain companies, they have very strict limits.
Right.
Like, no, I'm not a chemical guy. Sure. Okay, you're right. You're not going to care the fact that I'm putting acid in your carbon steel tank. Yeah. Okay, so they'll say, well, I'll have to send it to the chemical person, or we don't have that coverage. I'm like, well, I know enough to go, this isn't going to work. You can't put a acid in a steel tank. You have to coat it or something at least. But I'm glad that they're getting rid of that. So, Because I have at least one other person designs, and I have to check and approve everything they do, which I need to do that anyway. But he's been doing it now for 3 years.
Well,
but he's not.
Here's the next big deal.
Okay.
They've also published a code case that allows you to use the 2025 edition of Appendix 47 now.
So
Code
dealer's
case 30.
choice or what?
Pretty much.
What applies to you?
No, it was the oopsie. Here's the correction now because we want you to keep paying for your stamp.
Well, I think, just like everything else, the code evolves based on current market applications, right?
Well, on top of that though, if you have an AI review it, it passes Hydro, which is supposed to be higher pressures and design criteria than anything it's supposed to see in the service. You've proven that it works. I don't. Now, given that you have seismic conditions and a couple of conditions, I'm not going to be putting on a bed to test that. And at least I don't know what the heck's going on with the new code book because we won't have it in house yet. I think you have a copy.
I do.
But he has his own copy. We don't have the
He has
copy
the,
yet.
the working copy.
Yeah. So I've heard rumors of that, but today's a good day. Anyway, where was I? There's certain criteria that I would still want to get a P to look at because if there's a fast acting closure on the thing, we're gonna buy it from a person that makes fast acting closures, and then I'm just gonna stick it on the end. Mm-hmm. But if for some reason I had to design one, I'm going to be going. I'm not at the limit of my expertise, but I have no one here to check that I did my work correctly. I need a third party to check it because that's just being good people.
Sound engineering
Yes.
and practical engineering too. Like
Ethical.
absolutely.
Yeah.
We've done a number of tank variations of late that are UL 142 fuel tanks, or we talked about API 650 earlier. We've started to look at a lot more double wall, and I know we've been also doing.
We've built a couple double wall tanks. None of our double wall tanks so far have been ASME on both the inner and outer wall.
Okay.
The very first one we did was just a containment. They wanted if there's a leak inside the tank, they contain it. So we just had a 2-inch perimeter standoff, and it was nothing crazy. There was no pressure. We had a permanent snorkel on the outside of it, so if there was pressure, they have other problems. The next one we did was a drain tank that we used as a test bed. So it was a smaller, I think 300 gallon tank, 3,000. Well, depending who you talk to, 3,000 gallons is still a small tank. 300 gallon tank, and that was a perfect test bed to actually treat it like a ASME pressure vessel for both of them. And we got a little bit of heck from sales, like why are we spending so much time engineering this thing? Like, because this is the perfect test bed to prove that we know how to do a double wall ASME tank. I don't want to have to do a double ASME tank.
A double. Yeah.
In the 20,000 gallon range, and go, yep, that was a mistake. Let's throw that one away. I'd rather not do it to any of them, obviously, but a 300 gallon tank is a lot easier to swallow. So we had it fully inspected. We put the extra rings on the nozzle, so you're not welding on pressure retaining parts. We then welded the outer shell on. We brought the inner shell up to pressure, brought the outer shell up to pressure, and tested just like we would test a normal tank, how you're supposed to do it. But once again, we're talking about designed to or stamped to. We had a flag sticking through the outer shell, welded to the actual pressure vessel down there that no one's ever going to see again. But it's connected to the right tank with ASME tag on it. So it's encapsulated, but it's been tested.
How do you check that? Check that nameplate. It's sticking out of the nozzle.
The code actually takes care of that.
Okay. Yeah.
Okay, so UG90, it has that. We'll go back. I love UG90. UG90 is where you can start for everything. Okay. So when we get into UG90, it starts telling you this is what your requirements are, and you have to comply with this. And then you have the authorized inspector that he's checking that as it goes. So some of the checks of the authorized inspector always has to do an internal inspection, required by code. He cannot not do an internal inspection.
Does that mean you climb in there?
Yes.
So I do have a question for you on that one, though. Yeah. If you're doing a double wall tank, like the one we last did that we pressure tested, it was only about a 1/4 inch gap. Do you put the bore scope in there, or you have one head open and look?
Well, this is where you've got to, so that authorized inspector can do that internal inspection.
Yep.
As he's building, he's going to have to come out
Yep.
at very specific
We're
times
going to
to
need hold
see
points
that.
identified.
And that's exactly what he sets. So this is the important part of when we get a job to build a code vessel, to sit down with the inspector before it starts and say, what do you want to see? Okay, the inspector that we have now, I know what he wants to see. We're doing just a plain ammonia tank. Okay, 35,000 gallon ammonia tank.
inside it.
I can walk inside it. I actually had a hydro for it this morning, and we had another job just like that one that we're building. The head's already on. They've cut the nozzle holes out. We've already checked all that. And while I was here doing the hydro on that one, I said, come crawl
Come
inside
look in
this
this one,
vessel,
yeah.
so you don't have to crawl through an 11 by or a what is it, an 8 by 12 manway.
Right.
Yeah.
Yeah, I'm getting a little
They're technically
on the large side for that anymore. I like my food, but as you're building it, you plan for that.
Yeah.
And you make sure the inspector knows exactly what you're doing and give him the ability to say, I want to be here when you get to this. Stop work right here so I can come see this.
And QC
and that's where
is going to capture that on like the inspection and test plan, right? And we're going to
well, we have what we call it a traveler or an
Yep.
inspection inspection checklist is what we call it in our quality control system.
Well, then this is a perfect question then for you. Like the way we designed the tank and had it tested, we were originally going to test it with just the inner shell, and so you can witness everything for leaks and everything like that. And then after that, we were going to then build the other shell and have it tested again. Is that the proper way of going about it?
So are we talking internals and external pressures? Or are we
Yes,
talking are we talking internal pressure on the inner vessel, external pressure on the inner vessel, and then internal on the exterior vessel?
Wait, hold on. Yes. Yeah, because what we also did to make sure we didn't collapse the inner tank, because we brought the inner tank back up to pressure.
So we're talking about multiple pressure tests.
Yes.
So we have to do one pressure test on the internal vessel.
Yes.
And we have to do that before we put the other vessel
Correct.
on top
Okay.
of it so we can see if it leaks.
Yes.
Then the next part of it is we have to pressure test the inner side of it. Or the space between the two vessels.
Okay.
So we have to make sure that
So
it doesn't leak.
That's a separate test.
That's a separate test.
And that's fine, but to accommodate that, if the tank's rated for 100 psi, and I make that outer shell 100 psi, I'm now putting 100 psi into the 100 external pressure in the inner tank.
That's why you got to run external pressures calculations
Yes.
on it and make sure that when we do the hydro, it's not going to collapse that internal vessel.
Okay. For what we're doing is a containment, so there should be never any condition where there's only external pressure. If there's only external pressure,
Right.
once again, something drastically is going on that's outside of design criteria.
So in both cases, for both vessels,
Yes.
we have to do a hydro, and we have to do the hydro based off of what the design of it is for internal and external pressure based on where that internal
We
or
didn't.
external
I know we
pressure
did the
is.
design of. We had a downcomer going through the center of it because they wanted a leak detection. So that one pipe had its own set of calculations with 100 internal, 100 external on it.
Yep.
Two different calculations. So, okay.
Yep. And that's exactly how you do it. You just calculate it for external and internal at the same time.
Well, I guess we didn't fail.
And
the
then,
first,
and then make sure that it works.
Well, I think it points out a really valuable thing that we, number one, have you as part of our Vector family, and your experience and your background with these systems, and have been a part of the development of ASME's codes and specific sections and so forth. And that knowledge you bring to Vector makes us a better, capable, and higher quality fabricator than some of the other people we've worked with in the past.
Well, I appreciate that. I try to be valuable.
Well, that's
I hope I'm valuable anyway.
Well, I'm glad we
All
were
right, you're
able
gonna
to
give me the best news of the day. That I don't want to.
that 47 got
Yes.
changed. Yeah.
Well, so the other thing I was going to tell you, the term person in responsible charge, it's no longer in the code.
Then who's in charge?
That's a good question. Who is in charge? But no, so they're just calling him a designer now.
Okay. Because you had designer, certified engineer, and like one of the criteria.
Yeah.
Yep.
So we don't address any of those. We talk about designers within the company and designers outside the company. That's all they talk about now.
like the principle of
I,
peace for
I,
a change.
I like
So,
this change.
and
yeah.
they physically state that it's acceptable to subcontract your design to an engineering firm.
Well, we've done that.
Yeah.
No, let me correct that. I've done that for other people before, because we've had a couple of customers that they don't have internal people for their audit tank. Like, okay, hey Vector, can you do it? And luckily, I've done it the last 2 times, so the new one is okay. Is it up to the new code? Yep. Have a nice day.
And we can Vector Systems can function as a fabricator or designer or both.
Absolutely.
Yeah, we've also designed our own. We have I think I forgot how many gallons it is. Like 95-foot long, two 95-foot long tanks in Thailand that they were so big they're built in position, and we didn't build them in Thailand. But
we designed them, and it's our nameplate that goes on it, right?
I believe it's not going to be our nameplate because we're not the manufacturer.
Okay.
Yeah, you're not the manufacturer, but if you did the design of it, what would have happened is we did the design, we sent the design to them, they would have had to review it, accept it for code compliance, and then they would build it.
And
then
from
we can have a
jurisdictions,
supplemental nameplate. Is that we would have a supplemental nameplate?
Nope.
No.
Okay.
Nope.
Well, the thing about it too is I don't know what other design criteria of Thailand, and so they had to review it, and what other jurisdictions are there, because I can't read Thai, so.
Sure. So engineering companies are not annotated on the manufacturer's data report. They're not annotated anywhere.
No.
So the code just physically says you can subcontract it to a qualified person. But if you do that, the manufacturer that's sending that work to that subcontractor has to do some variables. They have to say,
Yes.
okay, what's your experience? Give me evidence of what your experience is. And that's when they start bringing out the PE or the RPE or
Well,
whatever.
we do that as part of our vendor qualification anyway, and I think that's a real important step to not only qualify them from a quality perspective, but also, hey, show me you know how to build my design, right, or
Right.
something similar.
Well, on top of those, like we'll get a scrubber or a specialized piece of equipment. Like I could build the shell, sure. I am not a filtration scrubber expert. I can't guarantee we're going to get down to so many microns and this percentage.
Mm-hmm.
But I still review their tanks. Mm-hmm. So like, hey, we're going to do this, and they'll send us the code calculations. And luckily, since it is most times people use compress, there's a couple other variable ones which make it a little more challenging to look through. But I still know what I'm looking for. I'm checking to make sure the right materials are there. And some vendors and some suppliers decide to not send you the deficiencies page, which is a little questionable.
But of course, to be fair, they could just edit the deficiencies page to show nothing either if they're being questionable to start with. Right. So you have to go through and double check those things. But on top of that, though, like we'll get designs from customers like, hey, I want you to build this type of tank, and they'll give it to me, and we can't just go, cool, they've vetted it, let's just go for it.
No way.
I have to then ethically, I have to review the code, because I've played it. I was like, this was great 6 years ago. Not a thing anymore. I have to change XYZ item.
Well, we did conceptual drawings that someone spent a lot of time drawing up, only to find out that it's not able to be manufactured based on how it's drawn.
Yep.
The components that they imagine don't truly exist, and it wouldn't pass with the criteria that we're evaluating. But we're still doing the process design to say, hey, look, I think this is what you're after, and this meets all those requirements.
That being said, just like you said, like I said earlier, code and reality aren't necessarily the same thing. I can design a really cool looking code vessel that could never be made unless we have 3D printers.
I hope we get there soon, but
that hobby wise, I've thought about
Trying to figure a way to get my big machine to
do an XY thing, but
if I find a market that's suitable for it, I feel like we could justify it, but not right now. Yeah. Well, I'm going to wrap, but this was a really awesome tank conversation. I want to talk some more tanks in the future podcast. I think it's really valuable with the expertise and knowledge that you have to share a lot of that. It helps Vector Systems be a better, higher quality, and more proficient manufacturer of tanks and other process equipment. So I wanted to say thank you for coming on and discussing this with us. And I know you're busy, so thank you for taking the time to sit and chat and talk tanks for a little bit.
pleasant sidetrack.
Excellent. All right, well, that's going to wrap today's Process Systems podcast. I'm Vaughn. Tune in next time while we discuss other process systems applications.